So next, for problem number 3, we have if s is equal to 0 when t is equal to 0, calculate the position and the acceleration of a particle as it moves along a straight line after 5 seconds. If the velocity is equal to 5t minus 4t squared meters per second, where t is in seconds. Calculate the distance that the particle has traveled during the given time interval and its average velocity. So medyo mahaba-haba ano. So again, what we are going to do first is we are going to list all the given values. So given for number 3 or problem number 3 is velocity is equal to 5t minus 4t squared meters per second, and also the value of t, which is 5 seconds. So in this problem, we are required to find the value of our position and our acceleration when t is equal to 5 seconds. So for our solution, first we are going to solve for the position. So again, our formula for position is v is equal to ds over dt. V is equal to ds over dt. So we have a value of velocity here. So again, cross multiply v multiplied by dt. So to integrate both sides with this will become 0 and s, and then integrate the other side, we will get 0 and t. So integrating, we are going to have s is equal to 0. So substitute the value of v here, which is the 5t minus 4t squared multiplied by dt. So simply integrate this equation. So 5t, we are going to have the integral of that is 5t squared over 2 minus 4t cubed over 3. There. So again, since this is 0, if we are going to substitute that value on this equation, we are just going to have 0, so we are not going to do that. So for this one, again, substitute this value on the right side. So since it is 0, we are no longer going to do that. So s is equal to 5t squared over 2 minus 4t cubed over 3. There. So the next thing that we are going to do is we are going to substitute the value of t, or our time, which is 5 seconds here. So our equation again, 5. So replace t with, or substitute 5 squared over 2 minus 4t, our 5 cube over 3. So calculating this will give us a value of 104.167 meters, or 104.17 meters. So this is our position. So the next thing that we are going to do is we are going to solve for the acceleration. So again, our formula for acceleration is a is equal to dv over dt. So the value of velocity is given. So substitute that value. Velocity is 5t minus 4t squared dt. So in this problem, we are just going to derive the values of this equation. So the derivative of 5t will give us only 5, and then the derivative of 4t squared will give us 8t. So again, we are going to simply substitute the value of t, which is 5 seconds. So 5 minus 8 multiplied by 5. So 8 times 5 is 40. 5 minus 40 is negative 35. So we are not going to put that negative. So that will give us 35 meters per second squared. So this is our value for acceleration. So another requirement in this problem is the distance. So calculate the distance that the particle has traveled during the given time interval. So we are going to solve for those time intervals. So in order for us to solve for that, we are going to use the quadratic formula. The given that we are going to use is the velocity, which is 5t minus 4t squared. So there is a rule in using the quadratic formula. This term should not have a value here. So what we are going to do is we are going to multiply this equation to 1/4 to omit this value. So dividing 1/4, multiplying 1/4 will give us the value of negative t squared plus 1.25. 5 divided by 4 will give us 1.25 t. So this will become our a and this is our b. So the formula for quadratic equations, or our quadratic formula, is negative b plus minus the square root of b squared minus 4ac all over 2a. So this is our quadratic formula. We are just going to substitute these values. So negative b, our letter b, which is negative 1.25 plus negative the square root of b squared, so 1.25 squared minus 4 multiplied by a, which is negative 1, and then c, which is 0, because we have we have no value for c. And then so 2 multiplied by a, which is negative 1. So since this is going to be multiplied by 0, this will be cancelled out. So we're just going to solve for the square root of 1.25 squared. So negative 1.25 plus minus the square root of 1.25 is simply 1.25 all over negative 2. So in this problem, we are going to get two values, because we are going to have the positive and the negative here. We are going to add it, and then we are also going to subtract it. So the first value of time, or the t1, let's say t1. So negative 1.25 minus 1.25 all over negative 2 will give us 1.25 seconds. So this is our first value of time. So if we are going to add this equation, we are going to get the value of t2, which is 0, because 1.25 minus 1.25 will give us 0 over negative 2. So that is equal to simply 0. So these are our time intervals. So we can write it as this. So the ends of 5 seconds, and then in our mid time interval, we are going to have 1.25, and then this will be 0. So our time intervals are 5 seconds, 1.25 seconds, and then 0 seconds. So we are going to solve for the distance from 0 to 1.25. So from 0 to 1.25. So again, to solve for the value of our position, we have the formula v is equal to ds over dt. So again, cross multiply. We are going to use the value of our velocity. So ds is equal to v dt. So integrating both sides will give us, so since this is 0 to 1.25, and then 0 to 1.25, because we are going to solve for the position from 0 to 1.25. So this is our time. So again, integrating this will give us s minus 0 is equal to the given velocity. So let us first substitute 1.25. So our velocity is 5t minus 4t squared multiplied by dt. So integrating this will give us s minus 0 is equal to, let us just remove this 0. S is equal to, there, so we are just going to integrate this equation. So integral of 5t will give us, and let us remove this. So integral of 5t will give us 5t squared over 2 minus 4. Integral of 4t squared will be 4t cubed over 3. 0 to 1.25. So again, since this is 0, we are no longer going to solve for that. So what we are going to do next is we are going to substitute the value of t in this value, so 1.25. So s is equal to 5 multiplied by 1.25 squared over 2 minus 4. Again, the value of t, which is 1.25 cube over 3. So solving for this will give us S1 is equal to 1.30 meters. So this is our position from 0 to 1.25. So now that we are done solving for the position from 0 to 1.25, let us now move on to the position, or the second position, or the S2 from 1.25 to 5. So let us write that down. So from 1.25 to 5 seconds. So again, our formula for position is v is equal to ds over dt. So para mapadali na buhay natin, we are just going to copy the value of the integrated form of the velocity, which is the 5t squared over 2 minus 4t cubed over 3 limited to 1.25 to 5 seconds. So we are going to just substitute these values sa ating variable, which is t. So S2 is equal to 5t. We are going to substitute 5 first. So 5 squared over 2 minus 4. Again, the value of t, which is 5 cube over 3. So this is our value for the 5 seconds, and then we are going to subtract it to the 1.25. So again, substitute the value of t. This time we are going to substitute 1.25 squared over 2 minus 4, 1.25 cube over 3. There. So calculating this equation will give us the value of our second position, or S2, which is 105.47 meters. There. So since we already have the value of our positions within the given intervals, within the given time intervals from 0 to 1.25 and then 1.25 to 5, we are going to solve now for the total distance, which is the summation of our S1 and our S2. So to solve for the total distance, S total distance, we are just going to simply sum up all our positions. So S2, which is 1.47, plus our initial position, which is 1.30. So adding this will give us a value of 106.77 meters. So this is our total distance. So another requirement in this problem is the average velocity. So in order for us to get the value of our average velocity, we are just going to simply divide the total distance to the given time, which is the 5 seconds. So our total distance, which is 106.77 divided by the given time earlier, which is 5 seconds, this equation will give us 21.35 meters per second. So this is our average velocity. So that is it for problem number 3.